Kia ora koutou. This video is going to go over some AS trig identities. So I'm making it for Ben, Tausif and Snehal for your lesson on the 15th of February, and I'm doing two examples from Mr Hawke's really lovely worksheet with lots of trig proof questions. I've picked out question 3 and question 14. Now question 14 has got reciprocal trig functions in it. So it's got cot, cotangent, sec and cosec. So you don't need those for AS, but we've already learnt them, so we might as well start playing around with them when we do some proofs. So I'm going to do two questions, and the first one is where we have to prove that this is equal to 1. I'm going to start on the left-hand side and slowly manipulate what I've got here, and I always want to keep an eye on where I'm trying to get to, right? It's kind of like learning how to drive a car. Always think about where you want to end up. Otherwise, sometimes you can end up back where you started. So let's look first of all, how we set it up. Well, we're going to write left-hand side, and then we just write out exactly what we've got on the left-hand side. And now we do whatever the obvious next step is. Only in this case, there are a couple of obvious things that we could do. The first thing that we can do is we can substitute in that tan of theta is equal to sine theta over cos theta. And that's quite a good approach often, and that's what Mr Hawke has done in his written work solutions that are up on Google Classroom. But I'm not going to do that this time. I'm going to work with that tan theta, or tan squared of theta, and see where we get to. I'm just going to expand out the brackets, and I'll get this 1 plus tan squared theta minus sine squared theta minus tan squared theta sine squared theta. Okay, now I want to end up with 1, and I know that about the only real trig identity I've got in AS is cos squared theta plus sine squared theta is equal to 1. And if I look in here, I can see that starting to happen here. So let's just reorder it. We've got 1 minus sine squared theta, and then I've got plus tan squared theta into 1 minus sine squared theta again. And we can replace this by cos squared theta. So I've got cos squared theta plus tan squared of theta, which I'll now replace by sine squared theta over cos squared theta, times this, which is cos squared theta. So I've actually done two things in that one line. I think that's okay, but you don't want to do any more than maybe two steps rolled in together. I could have written this out with an extra line where all I did was that change, okay? But I think you'll run out of patience with me if I do that. So here we go. We can now simplify out the cos squared theta factor here. And so we're left with cos squared theta plus sine squared theta, which equals 1. So the last thing that I'm going to write is equals the right-hand side as required. So that's our first little trig proof done. Let's look at this next one. So the next one gives me a lot more choice about what to expand out where, right? Like I could substitute out, instead of the tan, I could put in sine over cos, and instead of the cot, I could work with cos over sine, and so on. But again, I'm not going to do that just yet. Okay, so I'm going to start on the left-hand side and see what I've got. Just let me clean up the screen. Oh, something's gone wrong. Okay, so this time I'm going to be using more than just my basic identity. So we're going to start by having a look at what we've got. We've got sine squared theta plus cos squared theta is equal to 1. But remember, we can generate some more identities by dividing through by, first of all, if we divide through by sine squared theta everywhere, we get 1 plus cot squared theta is equal to cosec squared theta. Right, so that's my first kind of second Pythagoras identity. Right, and that's useful. Then I can do the same thing if I divide everything through by cos of theta, cos squared of theta. So if we start again with my basic Pythagorean identity, and now I divide by cos squared of theta, and cos squared of theta. So that gives me the one that is slightly easier to remember. Tan squared of theta plus 1 is equal to sec squared theta. And I think at AS level, if you're going to use those identities, you should show where you got them from. So it's fine to do that before you get into the question. And then you can just write a note saying, will be used in my proof. Okay, and you can even give them little labels. So you can call that one star star and that one star. Now let's get going. We're going to start on the left-hand side and we're going to look at what we've got here. So 1 plus tan theta squared plus 1 plus cot theta squared is the left-hand side. And that equals 1 plus tan squared theta plus 2 tan theta plus 1 plus cot squared theta plus 2 cot theta. Now if we regroup that, what we get is this one is equal to sec squared theta and this one is equal to cosec squared theta. And then we've got plus 2 times tan theta plus cot theta. Now I'm going to put a note here saying using star and star star. If we look at where we're going, we can see that we're nearly there, which is pretty cool. So on the right hand side here, we've got sec theta plus cosec squared theta, plus cosec theta all squared. And we know if we expand that, we're going to have sec squared theta plus cosec squared theta plus 2 times this times this. So what we've got to do now, looking down here, is we have to work on this last bit here and show that it works out to be sec tan plus cot, or tan theta plus cot theta, works out to be the product of sec theta plus cosec theta. So we're just going to do it sitting in the proof. We've got sec squared theta plus cosec squared theta plus 2 times, right, now it's finally time to substitute in sine theta over cos theta plus cos theta over sine theta. So that equals sec squared theta plus cosec squared theta plus 2 times, getting a common denominator now, cos theta times sine theta times, so now I've got the sine theta here multiplied by this, so sine squared theta plus cos squared of theta. And we really like that because that numerator is equal to 1. So sec squared theta plus cosec squared theta plus 2 times 1 over cos theta sine theta. I'm going to do this really slowly in case there's anyone else watching that needs me to go a little bit slower. So there's time plus 2 times 1 over cos theta times 1 over sine theta, which equals sec squared theta plus cosec squared theta plus 2 sec theta cosec theta. And that equals sec theta plus cosec theta squared, right? So this is my lovely perfect square pattern, which is the right-hand side as required. So there you go. So that's another way to do that question. So I strongly recommend if you are doing AS and you're in our 12 MCA class or your Ben, Tausif and Snehal, that you look at Mr Hawke's written answers, because you'll see that he's used that other method where I substitute sine theta over cos theta every time that I see a tan theta. Sometimes that works out really well, sometimes it can be a little bit slower. It's up to you, and the more you do of these, the more comfortable you'll get with your favourite ways of doing them. So please leave me a comment, guys, if you've got questions, or shoot me an email, and I'll do a few more trig videos for you over the next couple of days. Thanks for watching.